Hello scholars, today we will be talking about tides. Now tides are widely misunderstood. The next thing that I might say may be mind-blowing to you. The tide doesn't actually go in and out. What happens is that there is a bulge of water, two of them, on opposite sides of the earth, caused by the sun and the moon. And Earth turns inside of that bulge. So when we say the water rises and falls, what's actually happening is that we are rotating into the bulge of water and then out of the bulge. So the bulge is already there. The bulge of water is already there. We're just passing through. So the water gets high and the water gets low. So we're stuck in this language of our own perspective, what we see, instead of what's actually going on. It's more simple to say that the water goes in and out. It's also simpler to say that the sun set instead of Earth rotated such that our angular view of the sun fell below our stationary horizon. That's just we don't say that. It's a lot easier just to say that the sun set or the sun rise. But let's go ahead and move past that part and look at the moon and the sun. The sun actually has its own tides on the earth. And the tides that are caused by the moon are the same no matter the phase of the moon. So no matter what the phase is of the moon, you're still going to have the same amount of pull by the moon. Now, I've heard before that a lot of people say that a lot of crazy stuff happens during a full moon. And they basically relate this to water pooling, and because we have so much water in our own bodies that the moon is having this effect on us, and that's why we're acting crazy, whatever people say. But that's not actually true, because the amount of pull from the moon that gravity has is the same no matter the phase of the moon. So when we have a full moon, yes, our tides might be higher, but it's not because of the moon. It's actually because the moon, the earth, and the sun are in line. And the sun actually contributes to this pull, and the sun's pull and the moon's pull, they coincide together and will actually have a higher tide because they're in line. So now that we know that we have the highest tide when the sun, the earth, and the moon are all in line, when would we have the lowest tide? That's right, when the moon is actually at a 90-degree angle to the sun. So when the sun is at 90 degrees, the sun is pulling one way and the moon is pulling in a different direction, and the waves basically cancel each other out, which makes the lowest tide, and that's called the neap tide. So now that we have that understanding, I want to go ahead and look at the earth and the moon. So the side of the earth that's closest to the moon feels a stronger gravitational pull to the moon than the side of the earth that does not face the moon. So I'm going to say that again. The side of the earth that is closest to the moon has a stronger gravitational pull to the moon than the side of the earth that does not face the moon. So the moon is always exerting a gravitational pull on the earth. And there's a difference in the gravitational pull on one side of the earth versus the other side of the earth, depending on where the moon is located. Because there's a difference, it's pulling one side harder than the other side. When this happens, it ends up stretching. So the water stretches along the line where the tidal pull is pulling. So as we have discussed, as the moon travels around the earth, it's going to pull the water. It's going to pull the bulge of water around with it. And the sun will also contribute to this pull as well. And depending on where the moon is located, and if the sun, earth, and moon are all in line, you're going to have a greater bulge if they're all in line versus if the moon is 90-degree angle towards the sun, where they kind of cancel each other out. You're not going to have as great of a bulge of water as if they were all in line. So it turns out that we, the Earth, is rotating faster than the time it takes the moon to go around the Earth. So a day is shorter than a month. Now the moon is actually tugging on that water, trying to line it back up because the Earth is moving faster. Well, the moon is trying to pull that water, trying to pull it back so it's in line. And it does that against the wishes of our rotation. So the tidal bulge is actually slowing down the Earth. It's slowing down the rotation of the Earth. And that's why we have leap seconds. So the tides are not only responsible for what we perceive of the water going in and out, the tides going in and out, it's also responsible for the slowing down of the rotation of the Earth. And the Earth has been slowing down ever since the moon has existed. And we know this because there are mollusks that have certain features in their physical body that attract to the phases of the moon. Now there's a record of the cycling of the tides, and we have evidence of those cyclings that occur in a calendar year. And back then, there were more, which means that Earth rotated faster back then. And scientists were able to show this from these mollusks.